Let's start with number 6. Right. So our job here is to find the slope of the tangent line at this x value. That's what always we'll say. We'll say the slope at some x value. And it's kind of funny to me that they give you the y value here in your book because they don't need to. And I think they should have you, figuring some things out. If we wanted to know the y value, we didn't have it. We just take the -2, put it into the function, and we would get -2. So there's something to think about. So if we need to remind ourselves the general form of this limit that we use to find the slope, c plus delta x minus f of c over delta x, and of course c being -2. So we want the limit as delta x approaches 0 of f of c plus delta x, -2 plus delta x, 3/2 times -2 plus delta x plus 1. That's that first part. That's f of c plus delta x minus f of c, and of course that would be if we put -2 into the function, which they already tell us would be -2 over delta x. Alright, let's start cleaning it up. 3/2 distributed to -2 would be -3. This would be plus 3/2 delta x plus 1 plus 2. So we have 1 plus 2, that would be 3. -3, they cancel each other out. Let's not confuse anybody. Let's put delta x down here. -3 plus 1 plus 2, they cancel each other out. So let's rewrite this limit. Delta x approaches 0. And we see delta x's are going to cancel each other out now. And this is the limit. Just 3/2. Put in delta x into this, which there isn't one. It doesn't affect it at all. And you get 3/2. The slope at -2 is 3/2, but the slope at any point on a line is going to be the same as any other point, 3/2. But we have assurance that we did our work correctly. Let's go with number 10. H of t. Okay, I'm not gonna, well, I will. The limit as delta x approaches 0, f of c plus delta x minus f of c over delta x. And of course we could substitute h of t, and so that all should translate pretty simply. So c plus delta x, that's -2 plus delta x, -2 plus delta x squared plus 3. That's quote-unquote f of c plus delta x. We could say it's h of c plus delta x, but either way. Minus h of c, okay, and c is -2. If we put -2 into here, we would get out a 7. That's what they're saying. So we start to clean it up. This is going to be a positive 4 minus 4 delta x plus delta x squared plus 3 minus 7. Alright, over delta x. 4 plus 3 is going to be 7 minus 7 is going to be 0. So all these work together to cancel each other out. negative 4 delta x plus delta x squared over delta x. You can see canceling, one of these guys gets canceled. It's the same as factoring out a delta x and canceling out that delta x. Plus delta x. So this one we do wind up with a delta x in this final limit, but then we substitute 0 in for it, and we find that the slope of this thing is negative 4 at negative 2. So at x equals negative 2, the slope of that graph is negative 4. Pretty cool. And that's what we were supposed to find. Number 13. And we're supposed to find the derivative. All right. The derivative would be, rather than putting in c, c is like just anything. C is like x. It's not c equals 3 or c equals negative 2 or anything like that. It's just c is anything. It's kind of like we're finding all the slopes of all possible c values all at once. In a way, we are. Limit as delta x approaches 0 of f of c plus delta x. Right? Remember that we have this limit. Okay, but we're not going to use a c. Rather than talking about c, we're going to generalize it and say any x that we want to use. So f of x plus delta x would be negative 5 times x plus delta x minus f of x, which is just negative 5x over delta x. Negative 5x minus 5 times delta x plus 5x over delta x. Negative 5x and positive 5x. If it doesn't hurt your brains, we can imagine that these are, they're gone. I could rewrite them, I would rewrite this whole thing but just not write those, and we would have just this left, which would cancel these delta x's. So what's left is negative 5. That's the derivative. Because the slope of this thing at any point is going to be negative 5. So it doesn't matter what x value I pick, it's just going to be negative 5. That's why there's no x component here. Let's look at something that winds up being a little different. 19. F of x here is going to be x cubed minus 12x. Alright. Limit as delta x approaches 0 of x plus delta x, f of x plus delta x, f of x plus delta x, which would be x plus delta x goes in here for x and it gets cubed, minus 12 times x plus delta x minus, okay, that is, right, this big thing is f of x plus delta x. We put an x plus delta x in for all the x's and use that to rewrite this, minus plain old f of x, nothing different. All of this is going to go over change in y over change in x. Should invent a symbol for this thing, write it so many times. So we're going to cube this. It's going to be x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus distributing the 12. These things can get rather large. The good news is, though, once you expand it out like this, you can bet that a lot of stuff is going to cancel. like, let's look at x cubed. I'm going to cross it out because I look all the way down here and I see another x cubed. And let's look at negative 12x. It's going to cancel with this positive 12x. Now as I go to rewrite this, notice that everything that canceled was something that didn't have a delta x in it. Everything that's left does have a delta x in it. Think about what that's going to do. Well, what's it going to do to the denominator? Think about that for a second. Since every single one of these terms has a delta x in it, what's it going to do to the denominator? It's going to cancel it out because I could factor out a delta x from all these terms. Right? I could bring out this delta x in front. This would be delta x to the first, this is x squared. So let's undo that. Okay, so this is going to be, this guy's going to, it got factored out, so it's not there anymore. This guy's going to be to the first. This guy's going to be squared. And this guy's not going to be there anymore. And then delta x cancels with delta x. And let's look at what's left. It's still the limit as delta x approaches 0 of, now those delta x's have been canceled out. 3x squared, that's all that's been left from that one, plus 3x delta x, because we still had one left there, plus delta x squared minus 12. So now put in 0 for delta x. Nothing happens to this. This puts a 0 in here, which makes this be 0. Put a 0 in here, this is 0, and then minus 12. So here is a function that, by the way, we call f prime. Okay, we call this f prime of x. The derivative of x is called f prime. Anyway, if you put any x value in there that you choose, you'll find the slope of that tangent line at this at any point, whatever point you want of this graph. So let me rephrase it. Any x value on this graph that you want to know the slope of, you just take that x value, put it into f prime, the derivative, and it tells you the slope. It's quite amazing. That was 19. Let's go with 34. So this is kind of a fun one. What they're saying is to find the equation of the tangent line. What we've been finding so far is either the slope of the tangent line, just the slope, not the equation of that line. Or else we've been finding the derivative. The derivative is the one that gives us the slope no matter what. Okay, so now what we want though is the slope of, or is the equation of the tangent line. That's what they're asking for. So the equation of a line that's tangent to this graph, and that tangent line is going to be parallel to this. So first, let's find out more about this in terms that makes more sense to us. So I'm going to add y to both sides, and I'll find out that y is equal to 3x minus 4. Okay. And all that it tells me about, or tells me to use about this, is that the tangent line of this thing is going to be parallel to this line here. And for this line, the slope is 3. So the slope of the tangent line for this guy is going to be 3. Okay. So I need to find, I know what I'm looking for is the equation of a line. So let's look at the end result I'm looking for. Y equals mx plus b. This is my favorite form to write it in, slope-intercept. Well, I've got this. It's given to me here. It's going to be 3. What I need is b. And we never really talked about how to use any of these tools to find the y-intercept of the tangent line. Nothing is really straightforward that way. But what I could do is find the point on this graph, the x and the y, that align with a tangent line with a slope of 3 goes through here, and here's how. I can find the derivative, f prime, and that will tell me, for any x that I put in, the slope. So first let's find the derivative. Okay, so that's the limit, that whole limit thing, of x plus delta x cubed plus 2, okay, that's f of x plus delta x, minus f of x, x cubed plus 2, no fancy frills or anything, just plain old f of x, all over delta x. So we're going to cube this out, x cubed plus 3x squared delta x plus 3x delta x squared minus x cubed minus 2 all over delta x. Right, let's clean this up a bit because we have some stuff canceling each other out. Remember from our previous experience, we should get anything that does not have a delta x in it to cancel out. And of course I've missed something here. You might have noticed I cubed all of this out for f of x plus delta x, but I didn't put the plus 2, so maybe I'll just put a different color and say right in here I was supposed to have written plus 2. So now we can see plus 2 and negative 2 are going to cancel each other out, and only things that have a delta x in them are left. 3x squared delta x plus 3x delta x squared over delta x. And this delta x is going to cancel this and one of these, turning this into delta x to the first. So it becomes the limit now of 3x squared plus 3x delta x. Put a 0 in for delta x. Here's a delta x that goes to 0, so all that's left is 3x squared. Okay, now what did that give me? This is f prime. F prime of x is 3x squared. It's the derivative. It's the function that for any x I plug into it, I will know the slope at that point. Okay? But here's something I know. The slope at the point that I'm interested in is 3. Okay? So 3 is equal to 3x squared. So now I'm going to solve for x. This is the x value that has the x value for this function, whose tangent line to that graph is going to have a slope of 3. So we divide by 3. 1 is equal to x squared, and of course x is equal to plus or minus 1. Either one of those should have a slope of 3. And it seems to make sense to me. Yeah. Because I'm just thinking in my head of the graph of x cubed plus 2, it's going to have this shape. And you can see that, maybe here and here we're going to have a slope of 3. So we actually have 2 points, or 2 x values. One of them is at negative 1. Okay, so negative 1, comma, What's that going to be here? I put a -1 in here, I cube it, I get -1 plus 2. That's going to be a +1. Okay, and I have another one, like 2 lines. A +1, comma, put a 1 in there, cube it, get a 1 plus 2 is 3. So now I have two y values. I think probably the most straightforward way would to find the equations of the lines, is what we're looking for here, is just maybe put the y in for y, the slope in for the slope, the x in for the x, and then solve for b. This is -3. I'm going to add 3 to both sides, and I'll get 4 is b for this one. Let's do this one. We'll put in the y value for the y equals the slope times x plus the y-intercept. This is going to be a +3, subtract 3 on both sides, and I'll have 0 is the y-intercept for this guy. So y equals the slope times x plus the y-intercept. Y equals the slope times x plus the y-intercept. Okay, so we actually have two lines that are tangent. Alright, so I'm just going to walk us back through all this. They gave us a graph, or a function with a graph. It has a graph associated with it. They gave us the equation of a line in a funny way. We fixed it, put it in the slope-intercept form. And what they wanted was the equation of the line, not just the x value, not just the slope of the line, not just the derivative, but they want the equation of the tangent line. So a y equals mx plus b kind of a deal. The equation of the tangent line that's parallel to this. So we start pulling out relevant information. If it's parallel to this, it has the same slope. So the slope of this is 3. That's helpful. And then I don't know which x's for this graph are going to have this slope. So this might be something you try just as a whim. Just try it out. Because I don't have a specific x value, so I'm not going to just plug in an x and do the limit thing and find the slope. And that wouldn't really help because I already know the slope. So the other thing that we know how to do is to find the derivative. So let's find the derivative. So we find the derivative, and we say, oh, okay, so this function is going to tell me the slope at any x value. But I kind of have the reverse of that. I have a slope, and I don't know the x value. So I take the slope, right? The output of this is going to be the slope, and the output is going to be 3 for some x value. Then we solve for x, find out there's two x's actually that are going to have this slope of 3. And then we go back to Algebra 1 and find a line that goes through this point and has the slope. We put in the y value, the x value, the slope, find b, and plug b back in. And likewise for this other point. So we find these two equations that have this slope of 3 that are parallel to this line. Okay, so let me know if there's anything I can do to help. I hope that was helpful. See you next time.